Okay, so we're going to talk today about angle pairs. So yesterday we looked at angles, and how did you know ABD? ABD is this whole angle, right? How do you know that? It's labeled with the A here, the B here, and the D here, right? What would this angle be called? ABC or CBA, as long as what letter's in the middle? B, because B is the vertex. Very good. What's this angle right here?
CBD
or DBC. Very good. What's another angle name for the whole angle? ABD or DBA. Very good. So B always has to be in the middle. Could I just call it angle B?
No.
Why not? Youreth?
Because there's A, B, D, like
Uh-huh.
this one, and then there's also another one.
So that could be like the big one or the two little ones, so you have to be more specific. Good. If it were just one angle like this, then could I call it angle B?
Yes.
Yes, but just don't get in the habit of it. Just use 3 letters, because then you're always going to use 3. Okay, so what we're going to talk about today are different type of angle pairs and their relationships. And this is going to stick with us for the rest of the year. So these types of angles, these relationships between the angles, are relationships that you're going to need for the whole year. So it's just a very basic, fundamental intro to how angles can relate to each other. So these are called adjacent angles right here. We have 1 angle and 2 angle, and they're adjacent. What does adjacent mean? What do you think adjacent means? If I tell you that my room is adjacent to Mr. Vrandrick's room, what does that mean? Right next to each other. So we're next to each other. In fact, we share a wall, right? So that wall we share. These are 2 adjacent angles because they are right next to each other. All right, so angle A and angle B here would be adjacent. So does it look like these are also adjacent? Like angle 1, angle 2, are these also adjacent? Yes, but they also make a what? A line, which means they are also a linear pair. Linear pair is a pair of angles. Pair means 2 angles that make a straight line. Okay, so this is a linear pair. Linear pairs are also always adjacent. And again, adjacent means what? Right next to. Okay, so adjacent angles are right next to each other, and linear pairs are adjacent angles that also make a straight line. How can you remember what a linear pair is? It has the word line in it. Okay, so if it makes a whole line, then it's a linear pair. But because it's linear pair, it can only be how many angles? 2. Okay, so for example, this right here. Does this make a straight line? Yes, but how many angles is that? 3. So is that a linear pair? No. Okay, would they be adjacent? Yes, they would be adjacent to each other, but they're not a linear pair because pair indicates you can only have 2. All right? Okay, so in this figure, there's a lot going on in this figure, but in this figure, I want to know if they're adjacent and a linear pair, or not adjacent at all. So if they're not adjacent at all, what does that mean? Micah? Yeah, what does that mean? They're not adjacent. They're not next to each other. They're not next to each other at all. Okay, so looking at angles 1 and 2. So 1 and 2 are right here. Are these adjacent, linear pair, or neither?
Adjacent.
They're adjacent. They're right next to each other. But do they make a straight line? No. So they're not a linear pair. So these would just be adjacent. All right, I'm going to abbreviate that with ADJ. What about 2 and 4? Well, they're on the same line, but do they make that line together? So, like, this is 2, and this is 4. Are they adjacent to each other? No, because they're not next to each other. So if they're not adjacent, can they be a linear pair? No. So then here we would say neither. And then what about 1 and 3? 1 and 3 right here. Linear pair, so then they're also adjacent. Good. So ADJ and LP. If something makes a line, what kind of angle is that again? It's a straight angle, which means it's how many degrees? Okay, just keep that in mind. All right, let's try these 3. 5 and 6. 5 and 6. So here's angle 5, and here's angle 6. Are they adjacent? Yes, because they share this wall. All right, and do they make a line? Yes, so these would be adjacent and LP. What about 7 and SPU? 7 and SPU. So where is SPU? Where does SPU start? Right up here, and then it goes down here and then to the U. Okay, so there's SPU, and then here's angle 7. Are those adjacent? It's kind of confusing. Why do they look like they're adjacent? Do they share a wall? Yeah, they share a wall. Why aren't they actually adjacent, though? Okay, not all of them are next to each other. Where is 7? Describe 7 in relationship to SPU. Okay, so they share one line. That's true. Yeah, it's inside of it, right? If adjacent meant inside of, then if I'm adjacent to Mr. Vrandrick's room, where would our classroom be? It'd be like a mini classroom inside his classroom, right? Is that what adjacent means? No. So this one is not adjacent because it's actually inside of it. Okay? So then if it's not adjacent, can it be a linear pair? No. So this one is neither. All right, that's kind of a tricky one. And what about 7 and 8? What about 7 and 8? So we still have 7 right here, and then 8 is over here. Are they right next to each other?
Yeah.
What's 7 next to? P and 5. So is it right next to 8? No? Is there something in between them? Then are they adjacent? No? It'd be like, who's next to Mr. Vrandrick? Dr. Holden? Yeah. It's like we have a neighbor in between us, right? So are these adjacent? No. So then can they be a linear pair? No. All right, so that one's neither also. These do share a vertex, but they don't share a wall. Okay, and then we have 3 more pairs. I don't know why I have vertical angles on here twice. I think it's only on your slides once. I thought you couldn't see it on yours. Okay, so we have 3 more pairs. We have supplementary angles, complementary angles, and vertical angles. Vertical angles are going to be the most common ones that you see that we use over and over and over again in geometry. All right, supplementary and complementary, you guys might have heard these before. What does supplementary mean? Or what does it look like it means if you don't know? Martin? Two angles that make 180. Perfect. So it's 2 angles that add up to 180 degrees. Now you're looking at that and thinking that's not any different than a linear pair, right? Because right there that looks a lot like a linear pair. Supplementary angles do not have to be next to each other. So for instance, this right here, if that were 40, and this right here, if this were 140, even though they're not right next to each other, they're still supplementary because they add up to what? 180. Okay, so that's the difference between supplementary and linear pairs. Linear pairs have to be right next to each other. Supplementary don't. What do complementary add up to? 90. Yep, they make a 90-degree angle. So if this is 50, what would this be? 40. Good. All right, so complementary angles are two angles that add up to 90. Which makes what kind of angle? Good. Do they have to be next to each other? Nope. Also do not have to be next to each other. So one could be over here, one could be over here, as long as they add up to 90. All right, what do you think vertical angles are? If you had to describe it to me. What's happening with 5 and 6 here? They're across what? They're across from each other. They share a vertex. They're opposite of each other. So vertical angles are opposite to each other. And they share a vertex. They are congruent. They are congruent. So I'm going to abbreviate that with the congruent symbol. And that means that if this is 60 degrees, this one is also 60 degrees. So vertical angles will always be congruent. All right, so we have 5 angle pairs. We have adjacent angles, linear pairs, supplementary, complementary, and vertical. The way that I remember supplementary and complementary, the difference is supplementary starts with S, so does straight line. So that's how I remember, like 180 has to be 180. All right, but supplementary, it's also a bigger word, so it's more degrees, 180. Complementary is only 90. Okay, so at your boards with these, identify them as either adjacent, vertical, complementary, supplementary, or a linear pair. You can abbreviate those as you guys want. So you can just use A, V, C, S, and LP. If it's LP, it also has to be adjacent. So A. Okay? And if they're none of them, then put none. But I don't think any of these are none. All right, go ahead. All right, so when you are identifying angle pairs, the biggest key is to just try to isolate the angles that you're looking at. So for number 1, how come number 1 was not a linear pair even though it looks like there's a straight line there? Because there's 3 angles. You would need this one, and then it'd be a linear trio. All right, so if I tell you that angles are supplementary or complementary, you know that a supplementary angle has to add up to what? 180. So if I tell you this is 123, what could you do to find the other one? Subtract it from 180. What would you subtract from here? Why? What's the difference? These are complementary, these are supplementary. So here I'm going to do 180 minus 123, which is 57. And then down here I would do 90 minus 67, which is 23. Okay, so for all supplementary angles, you're going to subtract from 180, and for all complementary angles, you would subtract from 90. Good. All right. In this one right here, this first one, what could you do? What algebraic equation could you set up here? Does it tell you they are equal? No, but what do you know about them? They add up to 180. So what algebraic equation could you write? Good. X plus 2x minus 3 equals what? 180. So then how would I simplify, or what could I combine over here? Which gives me what? 3x. And now what could I do? Plus 3 on both sides. I'm ready to solve. So then 3x equals 183. So then how do I finish? And x equals 61. All right, so then I plug that in right here. This is 61, because that's just x. So then how could I find the other one? Plug in 61, or just subtract this from 180. Either one of those would work. 2 times 61 is 122, minus 3 is 119. All right, what's the difference down here? There's 3 angles. They're still supplementary, which means they add up to 180. So before we start, I'm going to plug in the info that I know. So angle AEB is AEB right here. So I'm going to put 55 degrees right here. CED, which is this one, is 68 degrees. And then BEC, which is the one in the middle, is 3x. So what can I do? What algebraic equation could I set up here?
3x plus 55 plus 68.
Okay, so the only difference is how many am I adding together here? All 3 instead of just 2. So 3x plus 55 plus 68, and it's still going to equal 180. How do you know it equals 180? Still supplementary makes a straight line there. Okay, and a straight line is always worth how much? 180. Okay, so what would I do first here? Combine these two, 55 plus 68. Remember, when they're on the same side, you just add them together. So 68, 55 is plus 123.
Sorry to interrupt, Ms.
Yeah.
Angelina Ventura.
Sure. All right, what would I do now? Minus 123, good. 3x equals 57. And then how would I finish? How many times does 3 go into 27? 9. So x must equal 19. And if it asks me to find AEC, first I have to plug in, right? I'm going to plug in right here. So what's 19 3 times? 57? 57. So 57. And it's asking me to find AEC. So what's AEC? If it's this angle right here, what do I have to do to get that? 55 plus 57. Perfect, Annie. Why 55 and 57? Or how come those two? Why not this one? Yeah, I'm not trying to find that angle. I'm looking for AEC. So 55 plus 57 is going to give me 112? Okay, 112. All right, there's a lot of work there, but the equation will be the same every time. What do you have to do with these 3? Combine them, and it should add up to, if it made a right angle, what would it add up to? 90. Perfect. Okay, on your practice, don't do number 1, and then just solve for x. So just find x. Don't worry about the other angle bits. Okay, go. So you have 3 to do.